Good morning, class. We are continuing with our revision of the paper that we wrote last time. And this time we're starting off from number 4. I got a message from some who wanted clarification on the first one. I will work on it. I will send the answer to those who requested those questions. So now let us quickly go through some of the questions that we wanted. We are starting off from number 4. In the diagram that were given there, we have EF, the rectangle. The fact that they are talking about the of saying it is a rectangle means to say you need to know the properties of shapes you are talking about. If they say it's a rectangle, you must know the properties of those of the shape of the rectangle, where BD 155 AD, that, DC, that, and the angle of elevation from D to C. That is the angle of elevation from D to C. This is the angle of elevation. 22. Now, the question reads, calculate A. You are supposed to find this angle here. Calculate angle A. Now, in the process of calculating angle A, you are given AD and a BD. From these ones, from what you are given, let us look at it. We've got on that triangle. Now, you think of the trig ratios that we need to use them. Remember, we can use sine, we can use cosine, we can use tangent. So it means to say, here you must see which one. This one, which we are given according to this angle, this one is the adjacent. Now, if this one is the adjacent and this one is the opposite, this one being the opposite. From the trig ratios that we know, which one has opposite and adjacent, you realize that it is tangent. So meaning to say, in this case, you are going to use tangent. You are saying tangent A is equal to 155 over 475. If you simplify that one, if you simplify 155 over 475, it will give you a certain number. Now, from that certain number, that is where you now say arctan. You press second function, and then you press tan. From this one, you will have, if you want to find the angle A, you say arctan. If you press the second function, it will write tan in this format. It will write tan like this, 4 minus 1. So arctan of this answer, of this number, 155 over 475. 155 over 475. Now, you see, this one, it will give you the angle that we want. So you have 155 over 475. This one will give us a number. The number that you're going to have there, it is 180. This is 180. Sorry, it's 18, 07, it's not 180, 18, 07, 23, 23, 2215, 2215. This is the answer that you're going to get from the screen of your calculator. Now, because it's 18,07232215, you give your answer because these are degrees. You give them correct to 2 decimal places. Here you are guided by the units that you are using. 2 decimal places. 3 is less than 5. Sorry, 2 is less than 5. So you just write 18,07 up to here only. That is what you need to do. You need to be conversant with the use of the calculator and also taking into account to the degree of accuracy that is required. If you are not given the degree of accuracy, you will be guided by the units that you are using. Now, let us look at, we are supposed to find CF. Where is our CF? When you are looking at this one, we are looking at CF, which is the whole of this one. This is the whole side that you are looking at. CF up to here. Now, when you want to look at that one now, the best thing, what you need to do is, you are now looking at which triangle can you use in order for you to get that CF. In order for you to get CF. First of all, you have got, in this case, you are given, let us look at the triangle BCE. If we look at the triangle BCE, we need to find, on triangle BCE, you need to find this one. CF first. But CF first, simply because we were told that this one is a rectangle. So meaning to say this side D, B, and E, F, they are equal. So our challenge now is of finding this side CE. Now, here, what are we given? This one is the hypotenuse. And this one is the opposite. This one is the opposite. Now, which trig function has opposite and hypotenuse? The trig function that is that, wake up, it is sine, which is opposite over hypotenuse. Opposite over hypotenuse. Now, from this one, opposite over hypotenuse, that is where we go on to our triangle. Triangle BCD, we use sine. Sine of the given angle. So sine 22, it is equal to CE over 800. Now you make a CE the subject of the formula. Now you say CE, this one is dividing, passes on multiplying. If you say 800 times 22, 800 times sine 22, it will give you 200, and this one is going to give you 299, 299, 68. This is 6852 747. This is the answer that you are going to get. Now, when you look at this one, you are saying this one is your CE, but you cannot say these are the units that you are going to use. Definitely, from our previous analysis, we realized that if we are not given to how many decimal places we are supposed to round off, you will be guided by the units. The units that we are using here, they are meters. So it means to say you need to round off to 2 decimal places. You look at the third decimal position, which is 5. Now this 5, you round it off to add. You will add to this one so that it becomes a 9. So we have 299,69. 299,69. That will be our answer. Are you clear there? Right? Now, we want to look at number 4.2. Here they are saying, without the use of a calculator, calculate the value of, without using a calculator. Now, what is it that you need to do? Now, still on the same scenario that we had, we know that from our triangles, now from a 90 degree, you will remember 45 degrees. 45 degrees, I want to draw a triangle here. All right, let us draw our triangle. Let me say it is something like this, a straight line there, and then we drop a perpendicular. It is a 45 degree angle because they are saying without use of a calculator. So meaning to say, for a 45 degree angle, you must know that if this one must be 45, this one must be 45. Hence, the size that you have, the size that you're going to have here, this one is 45, 45, this one will be a 1 unit, 1 unit. And here, using Pythagoras theorem, this one is going to be root of 2. We use it when we are looking at a 90 degree, a 45 degree angle. We use an isosceles triangle, which is side 1 unit, and angle 45, 45. This angle here and this one, they are equal. Now, in order to find this one, you use Pythagoras theorem. 1 squared plus 1 squared, it is 2. And then the square root of that side is root 2. Now, sine 45, sine which is opposite over hypotenuse. Now, on sine 45, what they want, because here they are saying sine 45, so it implies that here it will be, if you have sine 45, sine 45 degrees, it is equal to 1 over root 2. Because since they said without using a calculator, you must know that sine 45 is 1 root 2. This one, the way they did here, here they used a calculator, and this is wrong. Because you're supposed to have had in the position of sine 45, you are supposed to have 1 over root, it is 1 over root 2. 1 over root 2. That is why I wanted to represent this one like this. Because this one, it has been rationalized. If you don't use the calculator, it will be 1 over root 2. Because they're saying without using a calculator, once this one is seen, it's a sure sign to show that you have used the calculator. Now, let us go on to cosine 60. On cosine 60, you use, on cosine 60, you'll be having an equilateral triangle. Don't ask if this one is an equilateral. I'm telling you, these sides are equal. And this one measures 2, this one is 2, this one is 2 units. Now, this one is 60 degrees. If you drop a perpendicular there, you have a 90 degree here. Now, this angle that you're going to have here, this one, using a Pythagoras theorem, this one will be 1, and this one will be 1. Now, if you use Pythagoras theorem, this one will be root 3. Because if you say 2 squared is 4 minus 1, so this one will be root 3. Now, cosine 60. Cosine, it is adjacent over hypotenuse. So this one minus half is okay. Minus half is okay. Now let us look at tan 10 degrees and cotangent 10 degrees. Now, if we have tan 10 degrees, it's unfortunate here they use, let us say tan 10. If it is tan 10 degrees, you know that because since they are saying without using a calculator, this one is just the same. Tan is equal to sine. Let me check. Let me move it up like this a little bit. If we say tan 10, tan, remember you are not supposed to use a calculator. Tan 10 degrees. This one is sine shorter way of working it out. Right, in this case, you have got tan 10 degrees times cotangent 10. Cotangent, it is 1 over tan. It's 1 over tan 10 degrees. Cotangent is 1 over tan. So it means to say with this one, you can now divide tan 10 into tan 10, 1. That is where we are getting this 1, because it is tan 10 degrees times 1 over tan. This one is giving us 1. Now, from this one now, simply because this one, sine 45, which is 1 over root 2, but it is squared. Since it is squared, this power belongs, you say 1 squared is 1. And then root 2 times root 2, it will give us this half. And then since we've got half minus half, this one will be 0. And hence you remain with 1. This is the answer that you get from the number. This is how you can work this one out without using a calculator. Now, the mistake that they did here was this one is a sure sign. They used a calculator. It must be 1 over root 2, not root 2 over 2. This one has been rationalized. Now, let us go on to the next one. We go on to number 5. For number 5, what is it that we're given there? This diagram, we have got Q, which is 30 degrees, R, 110 degrees, and the PR. Q, it is this one, 30. R, angle R, it is this one, which is 110, and the PR. PR, we are given PR is equal to RS. Now, since these ones are equal, mathematically you can indicate it like this. Because they're saying PR and R, no, PR and RS, it is this one. These are the ones that are equal. These are the ones that are equal. Now, in order to show that you have an understanding of what you're talking about, you can indicate using these lines. This line and this line are equal. You indicate like that. Determine with reason the signs of the following angles. Now we want to find the size of P1. Which is our P1? This is our P1. We want to find the size of that P1. Now, how can we best find the size of P1? Basically, on that one, since we know that in P1, we have got now this P1. When we look at this angle P1, it gives us an impression that if we take this angle here, this P1 and this angle Q. When we consider this triangle P, Q, R, this is a triangle. And if we consider this angle P1 and 30 degrees, if you take this one and this one, it must give us this angle here, which is outside. Sum of two interior angles. Two interior angles is equal to one opposite exterior angle. So you say P1 plus 30 is equal to 110 degrees. This is what you have. P1 plus Q, which is equal to R2, exterior angle or sum of interior opposite angles, because they say it with a reason. Now here you are substituting. With this reason, you earn a mark. Now you substitute in Q, you put a 30. Now you transfer this 30 to the other side. So it will be 110 minus 30. 110 minus 30, this one is going to give us 80, and this is our answer. So we are done with the first one. Let us go on to the next one. We now want to find P2. Which one is P2? P2 is this one. Now, P2, still using, because we were given that PR and RS are equal. Since these ones, PR and RS are equal, it implies that this angle here must be equal to this one. They must be equal. Why are we saying they must be equal even though we are not told? This one, there is a reason that you give. This side is opposite this given angle. Because the reason that you give, angles opposite equal sides are equal. Because this side and this one are equal. Now this angle, which is opposite this one, must be equal to the angle, which is this one, which is opposite to RS. The reason that you give, and that on its own, it will continue with us. Because here, there is a trick that one may say, when you look at this one, you just conclude to say, this one, PRS is an isosceles. You don't say it's an isosceles unless you have proved. Now, the most appropriate reason that you are supposed to give here on this one, P2 is equal to S1. Angles, we are saying angles opposite equal sides are equal. That is the reason. And this will continue. We are starting off with in grade 10. In grade 11, will be there. In grade 12, it will be food and drink. You must give the reasons that are appropriate. This one, it is the reason that you give them. Now from there, you go on to your, because we simply say on this part, we are supposed to find P2. We want to find P2. So meaning to say, you say P2 plus S1. P2 is equal to S1. So from that point, since P2 is equal to S1, in the position of P2, you can say P2 plus R. Which one is our angle R? Angle R, which is R2, is not R. Angle R2, if you take P2 plus R2 plus S1, this one must give us 180 degrees. You must give a reason why you are saying so. Sum of interior angles of any given triangle is equal to 180. You remember this one from grade 8. This reason from grade 8. So you are seeing it is continuing with us. Now, since S1 and P2 are the same, in the position of P2, you can replace it by, in the position of S1, you can replace it by P2. And then now you connect like terms. It is now a simple linear equation. P2 plus P2 to P2. Now you transpose this 110 to the other side. So it will be 180 minus 110. This one will give us 70. 2p2 is equal to 70. Hence, p2 you divide by 2 both sides to get 70 degrees. Now, this is a part where you are supposed to explain, give your answer together with the corresponding reasons, relevant reasons. Let us rush on to number 6. On number 6, you are given a quadrilateral N4 section where AD is parallel. This one is parallel BC. And B is equal to angle D. This angle here, this one and this one, they are equal. This one we are given. That is what they are telling us, that these angle B and angle D are equal. Prove that ABC is a parallelogram. Now, when you are proving that it is a parallelogram, you must know the properties of a parallelogram. Properties of parallelogram, those ones. Now you choose the most appropriate one that will satisfy the condition that you are given. Now, we have in triangle A, B, C, and the triangle, we've got triangle A, B, C, and the triangle A, D, C. These two triangles, because this one was given that they are equal. Now let us look at it. B, angle B is equal to angle B. This one is given. This one is given. And then from the two triangles that we're dealing with, the two triangles that we're looking at, A, B, C, and A, D, C. Now, with AC, this is the common line. AC is common to both. AC is common. Now, from there, that this one is common. Angle, line AD and BC, we are told they are parallel. Now, from that parallelism, you can actually tell that this angle, you can actually say this angle, let me indicate with the 3 lines like this. This angle is equal to this one here. A2 is equal to C2. Why? These are alternate angles. Alternate angles, which at times we normally say are Z angles. They are Z angles. This one and this one, they are equal. Alternate angles. Now, when you talk of alternate angles, you must spell out the lines that are parallel, where AD and BC are parallel. And also, since you have that one, because we're saying, in this case, you are supposed to prove, we are saying C1 is equal to A2. C1 is equal to A2. C1 is equal to A2. This is what you've indicated. And the reason being that they are alternate angles where AD is parallel BC. That is the reason. Now, when you look at triangle ABC and the triangle CDA, we are saying triangle ABC, and we are saying triangle ABC and the triangle CDA. These triangles, when you look at it, we are saying AB, this angle is equal to this one. We were given. Now, and then this one is equal to this one. And that side is common. So meaning to say triangle ABC and the triangle CDA, these ones are congruent. You are proving that triangle ABC is congruent to triangle CDA. You must give the reason. This one is the angle side. Right. Now, since these two are congruent, when you are talking of things that are congruent, you are saying those are equal in all respects. Since they are congruent, so it means to say this angle here, this angle here is also equal to this. Now, these, if these ones are congruent, you are also saying this side are equal, angles are equal, and this one here. So A, B, and DC, they are equal. The reason you're saying AD is equal to BC, these ones are equal. Since the triangle ABC is congruent to triangle CDA. Now, this condition is only true. Therefore, we can now conclude that this given shape here, A, B, C, D, this one is a parallelogram. The fact that these two sides, this side and this side, are now equal, you can now conclude, and this one being parallel, this is one property which qualifies this shape to be classified as a parallelogram. Are you clear with that? Right, now let us go on to the next one. Right, now let's move on to number 8. We are moving on to number, oh, this one we're done. We are moving on to question 7. In the quadrilateral is a four-sided shape. Diagonals AC, we've got diagonals AC, this one A, B, D, bisect. When they say these diagonals bisect, so meaning to say they divide each other into two equal parts. Bisect, they divide into two equal parts. So they bisect at O. So they bisect each other at O. If AC, we have AC, the whole of AC is equal to 4xy. So from here to here is 4xy. So meaning to say this one must be half of that. So it is 2xy. If you look at AO, it's 2xy. And this one is also 2xy. Because they bisect each other. BC, this BC, it is x squared. It is x squared plus y squared. X squared plus y squared. Implying that, okay. Now, BD, where is our BD? This BD is equal to 2x squared minus 2x squared. So meaning to say half of this one, if the whole of this one is 2x squared, so meaning to say this one is x squared. Because if you divide everything by 2, you are going to get x squared minus x, x squared minus y squared. And here we've got x squared minus y squared. X squared minus y squared. Because if you add these two, they will give us prove that A, B, C, D is a rhombus. Prove that A, B, C, D is a rhombus. Now, since we're supposed to prove that it is a rhombus, that one is our number 1. We are supposed to prove that it is a rhombus. Now, in proving that it is a rhombus, AO plus OC is equal to 4xy. This is the diagonal. AO plus OC, they are equal. AO plus OC is equal to 4xy. That one will give a diagonal. Now, if you want to find the OC, which is the half of 4xy, it is going to give us 2xy. This is what we have here, from here to here and from here to here. Is that clear now? Now, let us go on to the next one. BO plus this is equal to 2x squared minus 2y squared. This one is a diagonal. You divide it by 2, so it's x squared minus y squared. This is exactly what we did here. This is exactly what we did here. If you divide from here to here and from here to this point, that is how you could work it out. Now, if this one is a rhombus, the rhombus diagonals bisect at 90. Now we are from there we are saying if that one is a rhombus, the diagonals must bisect at 90 degrees. Now let us look at it. We have BC squared. Let us look at our BC squared. Now, if we look at this one, BC, because we were told that this one, because if this one is a rhombus, they must bisect at 90 degrees. They must bisect at 90 degrees. So, BC squared, that would mean to say this one is a right angle triangle. It must be a right angle triangle. So BC squared, this one must be equal to x squared minus y squared all squared plus 2xy squared. If now we have x squared plus y squared, which is this one, x squared plus y squared. If we square this part, take note, x squared plus y squared, if we square it, now it goes back onto expanding brackets. So this one as it is just the same as saying x squared plus y squared. It is equal to right y x squared, right? This one must be squared and y squared. This is what is meant by x squared plus y squared all squared. You are writing this one is repeating twice. Now when you expand this one, x squared times x squared, x to the power 4, x squared times y squared, it is xy, and y squared times x squared, it is xy. Xy squared, x squared, y squared plus y squared, x squared. It gives us 2x squared, y squared. And then you multiply y squared times y squared, it is y to the power 4. This is what we have. Now, let us look at it from another perspective. Definition, because I had written on this part which I needed. Right. Now, when we look at this other one, we are looking at BO. We are looking at BO. We are looking at BO and OC. We have expanded this one. Now we need to expand BO squared using Pythagoras theorem plus OC squared. Let us analyze and see what we get. BO, it is x squared minus y squared plus this one squared, which is OC. Now, if we expand this one, x squared times x squared, it is x to the power 4. X squared times minus y squared is minus x squared y squared. Minus y squared times x squared, because here you have, if you expand that one, it will give us minus x squared y squared minus y squared x squared. This is the expansion when you expand this one. So minus x squared y squared minus y squared x squared. These are like terms. They will give us minus 2x squared y squared. You expand this one, minus y squared times minus y squared. It is plus y to the power 4. And then you expand this one as well. If you expand this one, everything that is in bracket is raised to the power 2. So 2 squared for x to the power 2, x squared, y squared is this one. Now, from this one now, you collect like terms. If you collect like terms, this one and this one, they are like terms. So you are simply saying 4x squared y squared minus 2x squared y squared. It gives us 2x squared y squared. Now, when you look at this expression and this expression, they are the same. Since they are the same, it means to say this one is a rhombus. Here you needed to analyze this question. You needed to analyze it. Let us go on to number 7.2. PQRS, PQRS is a parallelogram. The fact that they are saying is a parallelogram, you must know the properties of parallelogram. Opposite sides are parallel and equal. This one is equal to that. Opposite sides are parallel and equal. Now, we are also given that SR is equal to ST. So meaning to say this one is SR is equal to that. We mark this one with the same line of magnitude. And then angle P, which is 120. Where is our 120? Our 120 is here. So this one is 120. What have we done here? We are just inserting the information we are given. We are just setting the information, we are inserting the information we are given. Now they are saying, if S2, if this S2 here, this one, this angle S2 is equal to, let me say this one, if this angle is equal to 4x, this angle, calculate the value of x. They are saying calculate the value of x. Now, what is it that you, here what we've done, we've inserted the information that we're given, and then we want to use it. Right, we've got R1 is equal to, when we look at R1, because we're told that this one is a parallelogram. So meaning to say, this angle here is equal to 120. Opposite angles of a parallelogram. This angle and this one, they are equal. And this angle here, this angle, and this one, they are equal. Opposite angles of a parallelogram. Now, this angle, let me use a different color here. This angle is equal to this one. Simply because we are saying angles opposite equal sides are equal. This side and this side are equal. This side here is opposite this given angle. And this side here is opposite this given angle. Now, angles opposite equal sides are equal. That is why we're saying this one and this one, they are equal from the information that we have. Now, from the look of things, let us look at what exactly are we supposed to find there. We're supposed to calculate the value of x. Since we're supposed to find the value of x, we're supposed to find the value of x here. Now, if this angle here is 120, First of all, we say P is equal, R1 is equal to angle P, opposite angles of a parallelogram, they are equal. Now, this angle, if this one is 120, what do you think this one will be? Angles on a straight line, so meaning to say this one must be, because if you take R1 plus, let me say, R1 plus R plus R2, this one must give us 180. Straight angle, angles on a straight line. Because this one and this one, the angles on a straight line. But now R1 is equal to 120. So we are saying this one is 120. Now, if we want to find R2, if we want to find R2, we are going to say 180 minus 120. So R2 must be, now this one here is 60 degrees. This is 60 degrees. Now from this 60 degrees, so this one also is going to be 60 degrees. Now from there, you can actually say 4x plus of this angle plus of this other angle, T. This one is going to give us 180. The reason being that sum of interior angles of any given triangle. This is what we're going to have. Now, from there now, we are here, they work it out differently, no problem. No problem. Let us go on. We are saying, so we have got 4x. 4x is equal to 180. Now, if it is 180, 60 plus 60, this is 120. So you are saying minus 120. Minus 120. Now 4x, you are saying 120 from 180. This one is going to give us 0 minus 0, 8 minus 4, 8 minus 2, this is 60. Now you divide by 4 both sides. Divide by 4 both sides to get 4 there 1, 4 there 1. So you remain with x is equal to 4 into 6 is 1 time. Remember, 2. 4 into 20, it is 5. So we are saying x is 15 degrees. This is what we have. Now, they work it out differently, but all the same, we have converged to the same answer. Now, this is the end of our lesson. And for today, next week, we'll be starting off revising paper 1. And this work that I've given you, I want you to check on the answers and the working. You may also have used a different method. As long as it doesn't violate mathematical rules, it's okay. If you use a different method, as long as it is correct, we can justify it, no problem. So this is what we have. You have a splendid weekend.